Well, thank you, Eric, and thank you all for attending 4 p.m. It's very impressive to have you here. The subject today is private radio networks, and I think the SCE presentation very much is in sync with what I'm going to be preparing or presenting. The presenters here, myself, I'm R&D director at Telewave-io. Bob Finch, who you all know, is CEO of Select Spectrum, who has very deep knowledge of what spectrum is available for licensing. And we also have, not in attendance here, but we have two representatives from NIST, which is the National Institute of Science and Technology, that are responsible for standards. And the last presentation we had was use standards wherever you can. And that will be my message as well in terms of private networks. So let me, before I start the presentation, what is the connection between, public safety and utilities? Both applications require the communication has to be available, it has to be secure, and it has to be reliable. So that's kind of obvious, but that's very, very key for public safety. Where public safety differs is that in most environments, the critical communication, which is called, it's voice, it's mission critical voice or mission critical push to talk. They're the kind of key uses that they have for the network. So in public safety, a first responder, whether it's fire, police, or EMS, have to respond in minutes and hours. It isn't like, hey, send me a video and I'll get back to you, or great, thank you. It is a life and death kind of decision. So that really makes the voice communication and the reliability of that absolutely critical. So that's kind of a very important point. Now for utilities, it's kind of the same thing. I mean, obviously if you have a disaster, we haven't had too many, well, I guess we have in California. It's the same sort of thing, but it usually isn't life and death necessarily, but it's getting people out to the site, reducing the number of truck rolls to get the system up and running. So in a way, it's also a critical application where voice, really the purpose is, hey, that here's a team, you're in charge, get it going, right? And then that drives the whole response. So the message for you, two takeaways. One is standards, which I think SCE did a very good job of presenting the value of that, and you'll see I'll emphasize that as well. And the second thing is the importance of reliable voice communication in the system, whether it's utility or whether it's a public safety requirement. So the way we're going to do this, I'm going to present most of it, and Bob will address and give you a snapshot of the available frequencies. It's like, hey, people throw around ban this, ban that, how do you choose? I think in the previous sessions that we've had discussions on, well, you got to do a site survey, and you got to design your system once you know the frequencies. But then the question is, what frequencies should you use? And that's where I think Bob can provide us some insights in terms of that. So let me kind of give you kind of an overview. I'll talk a little bit about Telewave-io and then also Select Spectrum, talk about public networks and some of the challenges for private networks. Then the key areas are, there'll be Select Spectrum overview, which Bob will cover. And then I'll talk about what are the new technologies that are around that utilities can learn from, and there's a big differentiation. I mean, in a way, public safety is also it's not a big market. It's a critical market, but it isn't big. And utilities are the same. Maybe people want to buy 10,000 handsets, they don't want to buy 1 million. Whereas a carrier, hey, you got 20 million users and no problem, So the trick is to leverage what the carriers do already. And that's kind of the reason for standards, implementation of standards. And then we'll just summarize. So let me, just a quick overview of Telewave. Telewave's been around for 50 years, 7,500 customers. My own background, I've had decades of experience from chips to systems. So I understand the issue there. We cover, several markets. Public safety is key, with the land mobile radio applications, utilities, mining, and transportation, and also government. So that's kind of generally the markets we serve. So let me talk about a little bit about the evolution of networks, which is, I think, for this audience, kind of you're pretty familiar with it. But what we call legacy systems are, narrowband systems, such as LMR, VHF, UHF to 700, 800. And the use cases, there's the SCADA and, P25 and so on, which are used and widely used. And there's a sense that somehow they'll become obsolete. However, if you talk to a fireman who is trapped in a basement somewhere, and you give him an iPhone or a P25 radio and choose which one you should use, I can tell you, they know. Because they know that there actually have been use cases where they've had firemen using basically an iPhone, and they didn't know didn't know that they were in trouble, right? So while there's a real evolution in broadband, which obviously is key to everything we do, there are, in certain applications, you do need that additional level of security for personnel. So in the public space, enough said, 4G, LTE, 5G is here, obviously. And we have the AMI, reading the whole suite of products and video, a lot of video capability there as well. That's actually not super necessary for either public safety or utilities, as many speakers have already addressed. It's great to have, but it doesn't solve the critical problem. So the benefits of private radio, again, you have the security, and all the other attributes of here, as far as latency and scalability and so on, which I think we've kind of discussed. Whereas with public cellular, I think SC already covered it. You kind of like, by the way, we'll take care of your needs and probably get obsoleted, and you're gonna have to pay more money. I mean, that's not unreasonable, because their business is primarily serving 20 million users, right? And you've got what, 5,000-10,000. It's not gonna happen. So, and but on the other hand, when there's a problem, the utilities and public safety, they get the brunt of the attack. Why didn't you do this? Why didn't you do that? So that's kind of where it kind of fits. So what are the challenges for private networks? There's limited spectrum, right? And that's where you need to deal with that. We can't change spectrum. You just got to figure out how to use it wisely. Then the security, obviously we've heard that already, and the harsh environments. I mean, a good, in public safety, you've got a fireman who maybe has a truck, has some access to communication, but he may need to use his LTE network, or he may need to use additional networks to allow him to communicate in a critical environment. There's also the narrowband IoT, you've heard already, just tremendous amount of information flowing through the various systems. And then the other thing is, how do you integrate legacy and the new technology. I hate the word legacy because it ain't going away, I don't think, real quickly. It's just a matter of existing versus newer technologies. How do you get the compatibility between the two? And I'll speak to that as part of the work that we're doing with NIST. And again, standardized interfaces. So this is the same tune that we heard from our friends at SCE. So these are the enabling technologies that that are forthcoming here. One of them is the basically smart spectrum, which I'll have Bob address in a bit. Then there's also software-defined radios. You'll see we have a exhibit at the tomorrow, which actually shows a software-defined radio. It's about 5 pounds, and it is fully 4G, 5G compatible. It's basically a standalone base station that you can use a regular iPhone to communicate. And I'll get into that a little bit further. And the other key thing is the legacy communication, which is LMR to broadband. And easier said than done, but we all know that that's a key challenge for all networks and private networks in particular. So the last item I want to cover is a little bit kind of further out there, is what we call network observability using AI. And it sounds kind of a bit out there, but basically data centers today are already so complex, worldwide, numerous sites where there's massive amounts of information, both on the plant and other parameters that are monitored, which is a real candidate for utilizing, they already use that, I should say, for data networks. And there's a carryover, I think, to some of the challenges for the utilities. So that said, I'd like to have Bob speak to the select spectrum offerings and some of the frequencies.
Thank you, Steve. And I'll mention now that Steve and I discussed this last night. We had a pleasant dinner outside in California, which was very good. And we both agreed that if you have questions, comments, observations as we go through this, I think there's time. We have a small but I think very knowledgeable crowd based on some of the faces I recognize. So, by all means, jump in if you have a question as we go, or if you, particularly if you think we've said something that isn't 100% correct. So we have been in this business actually with utilities for nearly 15 years. The company overall has been around for 15 years. We have a whole broadband side, public networks, wireless ISP side as well. But my focus in the business, I'm the founder, has been on private networks particularly for utilities and critical infrastructure. We represent more than 20 bands of frequencies, and many of those are useful to utilities. In this particular presentation, I'm focused more on the PLTE, and I'm really following Telewave. I think their significant interest is on the PLTE side, and Steve mentioned interest in standards, so I thought that should be the focus. But we certainly also support narrowband, wideband frequencies. We've been quite active in the upper 700 megahertz A block, for example. We mostly work for the parties that hold the licenses in terms of who our client is, but our business is really trying to develop applications, support the development. We don't do it ourselves, but we talk to the manufacturers, we talk to the consultants, we say, here's the licenses that are available, we're interested in the use cases, and to be honest, we're creating demand, right, for the licenses that we offer by helping with applications. So we're very interested in doing that. We have some of our clients will basically say, okay, if this is a new application that's not been used on this particular band of spectrum before, we'll give a special deal, like an introductory deal to create a new new solution, because that will drive more applications. So as utilities, as consultants, I see Sunny out there, by all means, come to us and say, hey, here's something I'd like to accomplish. we'd like to work with you to try and find out, okay, is there a good solution? Okay, so in terms of the bands that I would mention today, these are examples. I think they're the most relevant to the most utilities that are interested in the most standardized type frequencies. Again, there'll be different frequencies. The ones in bold are licenses that we offer. The other three that are in regular font are offered by other parties. So far, one of those, by the way, band 110 at 1.4 gigahertz, 1400 megahertz, is just kind of freshly arrived on the market. It's been bouncing around. It was a satellite-oriented frequency for a long time. And now they've seen an opportunity and just announced in a recent Spectrum subcommittee meeting, hey, we're here. That's a company called Midwave. The block size there is, you know, the maximum that's currently available. There's some complexity in band 106. People know Anterix. They've got a significant clearing issue that they're working on. So by all means, look into that. The upper 700 megahertz A block's been sold in about a third of the country, available in the other thirds. It's not true broadband, right? It's part of the 4G, 5G standards, but it only supports the narrowband IoT. Great for massive uses, not good for high broadband or low latency to a particular frequency. Band 54, we're excited about. This is Legato Networks holds these licenses. They have 5 megahertz time division versus frequency division. I think most of you know that situation. By having time division, you can allocate the entire frequency. If you have majority uplink, the vast majority, 80–90% of the capacity can be allocated to the uplink. That's common in lots of utility type applications. We just heard a presentation in the prior session from Southern California Edison. So they're doing the CBRS deployment. They bought CBRS PALs at 3.5 gigahertz. In general, I think most of the people know that the lower frequencies are going to propagate longer, right? So that's advantageous. The higher frequencies tend to have more capacity, not capacity per megahertz, but more, those bands are wider. If you get smaller cell sizes, you have to buy more sites, okay? But you also get to reuse that capacity in each site. So these are the kinds of things that really make sense to go through carefully. As we heard in the prior session, evaluate what is going on with your build and really what you're trying to accomplish. I'm going to show some band plans. I'm a graphical-oriented person, and this maybe helps to illuminate some of what's going on. So I'm going to start with the lower frequencies, upper left, 700 megahertz band plan. There's a lot of utilities in those green 1+1 megahertz, and they are supporting field area networks, and many of the utilities are pretty happy with the amount of capacity they're getting. Now, we have a push towards 5G, but it depends on the philosophy. We've had recent decisions from utilities to say, no, I'm willing to live with these wideband frequencies. I don't want to deal with the complexity of trying to operate an LTE network. That's an economical solution. It has capacity limitation. Because the propagation is good at these frequencies, it's certainly significant, and we would be glad to talk to you about those. In the 800 and 900 megahertz, it's worthwhile mentioning, so this is where Anterix is. This is where relatively recently announced Grain Management is in the process of obtaining these licenses from T-Mobile, and Black & Veatch is marketing these. They've also presented to the Spectrum subcommittee. By the way, for anybody interested in Spectrum or private wireless in general, I definitely recommend the UTC Spectrum subcommittee. So excellent propagation in these frequencies. The band 26 800 has a lot of deployed equipment, right? Because Southern Company is, well, first of all, this has been a carrier network under T-Mobile, so there's all those devices, but also Southern Company or Southern Link has a deployed network in these frequencies, so significant equipment available. Anterix has worked very hard to develop the ecosystem that's available at 900. There's still gaps, but they've made tremendous progress, and I admire what they've done there. A challenge here is, if you notice the red frequencies on either side of band 26, so that's carriers operating cellular networks. Similarly, you have other, push-to-talk and other applications going on at 900. These are relatively high noise environments. How many were here yesterday and participated in either the sessions or the cocktail hour? How many were here? Not, yeah, okay, fair enough. How loud was it after the sessions or during the cocktail hour? We were trying to have a conversation, right? And this is the same issue. It's audio waves rather than, and sound waves versus radio waves. But in these environments, there is ambient noise. And while the propagation is going to be better, you're also going to have to deal with those noise sessions. And I think we're going to try and get together a session on the subcommittee to deal with those. When Midwave announced, one of the things they pushed very hard was, hey, we're in a low noise environment, which indeed they are. There's going to be a fair amount of noise at 3.5 gigahertz too, I guess I should mention. So at 1.4 or 1.6 gigahertz, it's a very different situation. Propagation is not quite as good, but there's a very low noise environment. So when you run through all the numbers, and this requires getting pretty sophisticated engineering studies done, you may find that these low noise environments are adequate propagation, adequate distance, and in fact can deliver more capacity and could be more cost effective. So that's kind of an overall picture. I want to, as we said, Steve is going to really be leading the presentation today. Certainly take questions or comments now if there's any on Spectrum, or we can do it later. Yes, sir, in the back.
This is a really stupid question. I've always asked the question to myself. How are they coming up with these numbers like 26 and 40? I never remember them.
It's secret code. We just try to confuse people with them. That's the objective.
The order of release is like, okay, first band is this, just like 24.
Could be the ITU.
So
this is 48, which is like double.
This comes out of the 3GPP standards group, right? Also something that has a number to it because it refers to the old generation of cellular standards. There is some logic in that you'll notice 54 and 48 are in that range that's some time division blocks, but then 103 and 106 came later and 110 came later. So I would say, assume that it makes no sense. Look it up on Wikipedia if you want to know what the frequencies, or come by our booth number 544. With that, let me turn it over to Steve. I'll be here for more questions.
Good. Okay, everything you wanted to know about frequencies. I think the issue with frequencies are always challenging, and the question about bands, it gets worse. They stick N in front of it. N band something means it's a new radio. It keeps evolving, but I believe this comes from the 3GPP standards community, where it's kind of worldwide, the worldwide frequencies. So you got to be careful when you're changing things. You got to have agreements and votes and everything to do that. So, so let me get back to the next technology area, which I mentioned was software-defined radios. And so one of the things when you have all these frequencies to deal with, it's hard enough to say, well, band 103 or band 48 is CBRS. They kind of have common names as well as frequencies and bandwidths associated with them. The role of the software-defined radio, as I'll explain, is very key in as much as you can actually, once you have the 3GPP stack on the radio, you can configure the radio yourself. Now, what does that mean? Well, it doesn't mean you have to be an expert in it. You can set your transmit powers, your receive powers, your subcarrier, number of subcarriers, the subcarrier spacing, all these things you can control to the extent it's necessary for your application. So that's really the power. Plus, you can move the frequencies around, and that's a real, flexible feature because you've got these odd frequencies, that you're using, and then you try to use those. And also, if it's very narrow band, you can still apply the same control parameter or configuration parameters to a narrow band. It doesn't have to be 10 megahertz or whatever. So that's a very important part. So with our NIST program, one of the, I'll explain kind of what we're trying to do there is really the challenge of interoperability between broadband and narrowband LMR. So I'll explain some of the challenges there, but basically that was the objective, that coming back to voice, and really that's the message, voice and standards. Voice is often, it's more often used in it is used in LMR, obviously. And the question is, how do you get the interoperability? And that's really the purpose of the development. Go ahead.
There may be some who don't know what NIST is.
Oh, okay, NIST. So let me explain. So NIST is the National Institute of Standards and Technology. So the particular group we work with is, everyone has an acronym, PSCR, which is Public Safety Communications Research Group, right? So that's kind of their charter in life. And they get equipment from all the equipment providers that you know and love. And they kind of evaluate it in terms of, does this address the needs for public safety for them? Is it like, do the firefighters, first responders, objectively, what's the feedback, surveys, is this the right way to go? And where are the gaps in the technology? And that's kind of where we're adding value to what they're doing, right? So the particular radio that, actually you'll see this downstairs, this is a the 5-pound radio. It supports, and it has a full 3G PP stack on there that can do, you can either configure it to run 4G LTE or 5G standalone operation. And so that's quite a unique development. And as a 5-pound unit, let's say 1 watt, we see that in terms of use case, like cellular on wheels. This is almost like a cellular on a fire truck, or even on somebody's backpack, with some limited, half-hour operation, where everything's lost, all is lost, and people are trying to communicate. They may not, their P25 system may not be working, or they have, it's a redundant application for those systems. So, and obviously a number of other use cases. But basically, the software stack is loaded onto a processor, and then those drivers, which are the 3GPP drivers, drive the actual software-defined radio, which changes the frequencies and so on. And then the front-end module gives you the higher power as required. And so roughly, if you get it up to about 1 watt, you probably can cover a mile, with pretty reasonable coverage. So that's kind of the basic building block. So for interoperability, what we do there is, in the purple here is the radio itself. Then it's tied into a mission critical push to talk server, which is again a standalone unit. And then this is the LMR system, which is connected through a fiber to the LMR. And the block in the middle here is the ISSI. I don't know who is familiar with that, but basically it's called inter-subsystem interface, which essentially can translate voice from the broadband to the LMR application. So this particular white block is, there are standards for that as well. There are ETSI standards for that. However, in industry, each vendor has, I'm compliant with the standard, but they're not compatible. Okay, so that's a real issue. If you think of like a UE on broadband, you've got your iPhone, you can plug in different SIM cards, you can have multiple SIM cards in your unit, and it doesn't really care, it'll communicate with the network, right? So that's just fine. However, when you get into trying to communicate with the LMR, which which uses the authentication, the key to fire up your subscriber units, that also is taken care of. But that link is the key thing, and that's why this is an area that we're addressing in terms of standardization and looking for ways to simplify that process. So to date, we have demonstrated band 13. Sorry to use these numbers, which is the Verizon. Verizon. Band 54 is the AT&T FirstNet, which is obviously a very broadly utilized application for public safety. Band 54, which Bob mentioned, is the other one we're looking at for high power applications, TDD applications. And I didn't mention others like band 48 we've already done for CBRS. In that case, that system was used for factory automation, as an example. We're taking advantage of the low latency in 5G, so in a factory environment to implement that in a factory. So basically, again, the message is that we're using the standards overall and configuring the radio according to those standards. So, and that's the development that we have underway. So I mentioned then, these really the highlights, the fact that we've got, the seamless, we're getting seamless, trying to get seamless operation between the broadband and LMR. And the other function, again, for public safety is this mission critical push to talk. And we've heard that here, but some of them are what you call over the top, which actually don't use the network, but they do use the radio or internet connection. That's basically the what allows us to do the evolve the network. So another subject area, and this is probably a little bit further out here, is adapting what are called network observability using AI techniques. And I guess the buzzword we're using there is NOAI, just to shorten it. So basically, the issue there is that when you have a very complicated network, and many of the ones we've described, where you've got numerous remote sites, you've got power centers, you've got other relays and other things that you're monitoring, you like to be able to capture that information in a way where you can direct resources in the event of a problem, right? So that is a very, normally what happens, there's an event, somebody calls somebody, there's an emergency, or you get somebody gets a call, you don't necessarily get the big picture of what's going on. And so that's a real application area that we think is certainly fits into the network vision that we have. And I should have mentioned, is that the communication mechanism for the software-defined radio and so on is all IP related. We use IP traffic primarily to monitor the system. So that's kind of what's happening there. So kind of just a thought process of how network observability is already used for data centers, which is obviously a big deal. You're talking about data centers now that have their own utility. Frankly, it's kind of pretty getting out of hand. But basically, monitoring, a system as complicated as that, you have things of on-site power generation, you have electrical distribution, cooling systems, just monitoring the whole system. There are existing tools that data centers use already to do that kind of thing. So they have the monitoring, basically processing the IP traffic through their system. And so the idea here is to leverage that for private networks. So that's kind of the concept here. So in a private network, you know, this is sort of an example of how that might be done. You know, you've got a lot of shared information. You have SNMP, IoT, SCADA, and LMR, and so on. And you'd like to be able to monitor that, as effectively as you can. So on the right here, you've got kind of a typical site, which would have private cellular communications. You'd have digital I/O, which is detecting relays. You might have some SNMP, IoT, and so on, all active within that site. And then the idea is that you then consolidate that into a switch which generates the IP traffic, where you can apply the network monitor the network status. So that's kind of where it's headed when we look at how to integrate integrate the existing systems. So some of the other concepts there is where once you capture the information, you can actually create what's called a digital twin, where all of that information can be then analyzed offline while while the system is continuing to monitor the traffic. And it provides, I think most of us have used AI in some shape or form, realize that it does provide things that you don't have the, let's say, the mental memory of all the subtleties that are going on in the system. So we really think that is an area that will be very promising. So just in summary, we've talked about spectrum access. We've talked about the SDR utilization for both public safety and utilities. And then the key thing was the interoperability between the narrowband LMR and broadband, which is actually an ongoing development. The intention there is, again, to develop standards that you're somewhat vendor independent for that block that I showed, the ISSI block. And then finally, we touched on this observability concept for understanding the behavior of the network. So that's all we had, and these are some contact informations which in the presentation. And if there are any questions, we look forward to hearing from you. Yes.
So where does the AI reside, and where does all the data that the AI uses?
Okay. Right. Well, if you think of, the way I describe it is that when you're monitoring a very complex system, the IP traffic essentially populates, very crudely put, a CSV data sheet, an Excel spreadsheet, right? You imagine a big spreadsheet that has all of the data in it, just raw data, right? Then what the AI does, it looks at that data and interprets correlations between different functions. Now, the IP would allow you to address, well, is it a IoT device, or is it some other part of the system that is being recorded? But think of it, it's processing a big database with a lot of information on it.
Right. So where is that database? Is that in your server, or is that on somebody's server?
That'd be on your server. No, this would be on your system.
Over time, that database looms.
Correct.
You almost need a mini data center to get all of that.
Yes. Well, that's why the let's say the AI systems are getting very they're analyzing a huge amount of data, right? So you'd have to put some intelligence into it beyond just AI, saying, hey, we want blocks, or prioritize which areas are important, and then focus on those. Which ones are mission critical, which ones are maintenance related, and so on. You could prioritize that. But it is, when you think of, really SC would be better equipped to address this, but I think the amount of data, generally when there's a crisis, everyone looks, well, what happened, and then you have to, explain yourself. But in reality, you want to be able to anticipate when bad things occur. Now, fires are different. Fires are various events can occur, but then you have to know how to react to it and learn from it.
Steve, could I add?
Sure, please.
So it's dangerous, right? A spectrum guy talking about AI, but I happened to be at a recent meeting of EPRI. So EPRI has the 161G group. I'm sure you know Tim Godfrey leads that, and this was a very significant topic, right? The utilities saying, hey, we've got this data, can we share it with other utilities? Can we anonymize it? But the recognition that by running these networks, they have valuable information that can correlate what's happened in the past using AI to more quickly react to what's going on in real time. So to me, it's an exciting development. I'm not the only one. I mean, you're not the only one who has this question of where does the data come from?
Yeah, no, it's a great question. I mean, I don't know if the utility people are here, but I'm really curious what happened in Spain. Right, I don't know if you're aware, they lost power for a week or two, right? Nobody talks about that.
Actually, I just saw that, but it was on German news. They, the high-level government official, who's in charge of the electrical grid, they just released the report, right? I mean, it just happened.
Amazing.
It just happened. And there are no signs of a cybersecurity attack, but essentially it was an overload situation that then just cascaded, right?
Yes.
So it was I think because they had a lot of renewable energy, mostly solar, because they really have a ton, and it was with that connection between Spain and France, right? The interties, and something just didn't mesh, and that created that domino effect. And because Portugal just hangs at the end, they just they couldn't escape, right? They're just
very interesting.
So I don't know all the details because I only saw headline one paragraph, but it literally just happened.
That's amazing. Amazing. Yeah. Well, I think the answer is you're prioritizing. It's like people only care when you have the event, right? And they take for granted that your planes take off and land, all of this stuff, but it's the more information you get, that increasing that reliability an extra point in 99.99, we all want that, right? And definitely if you lose a week's worth of your economy, that's worth a lot, I don't care if it's Spain or anywhere, right? But I think that's kind of the thought process, because it's extremely complicated. And I think with the standards approach, where you're trying to get using IP traffic, you try and data centers already use tools to do that, right? So it's a matter of adapting. We're not creating new tools. We're adapting those tools to another application. And that's really the high level thing, because as I say, the carriers have tens of millions of, 20 million customers, and the utility maybe has what, 10,000, So you need to leverage what they use to improve what turns out to be more important than the carriers themselves. So that's really the message there.
It'll be interesting what SIP has to say about AI interconnectivity.
Yeah, well, we're looking into that. Yeah, very good.
Pretty much allowing the internet into your network, in your backyard.
Well, it's not the internet. It's private. It's private. This is not. It's private network, right? It's not a.
No, I'm talking about using the massive AI capability
Oh.
of carriers to help you
Okay.
do your thing without building your own data center.
Well, yeah, I think the private AI is also evolving. It isn't. See, I compare it now. Excuse the digression here, but we used to have IBM mainframes, and we use that, because that was the magic, as it were. The magic now is all these data centers that have all of our information. And the next step, obviously, go back to your own private, data center where you control your own information. So that's what I think is going to happen there. Any other? Go, yes.
Yeah, where is that SDR solution being used? Is anyone using that SDR solution, the software-defined radio, for the?
Well, yeah, I mentioned in factory order, it's a research, but in terms of commercialization, well, actually, in Europe, it's being used, I think I can mention by Vodafone, just, part of it. But in terms of full deployment, it's not there yet, but I think the use cases, we're defining the use cases for it at this point. But it definitely, it works. I mean, you can really, and that's kind of the key thing there too.
And it's functioning like as a full system, like on a 5-pound box?
Exactly. You can check it out. It's downstairs. You can see it. So it's, and to me, and again, coming back to the standardization theme, it isn't sort of some proprietary thing. You can do your own configuration. If you're familiar with, some of the 5G configurations, you can do your own, carrier spacings and things like that. You can program that yourself. You don't have to know the whole system. It's just what you need. So,
Thanks.
sorry, there's a question. Yeah.
Are they being mostly used for just data utilities, or are you trying to incorporate voice into it?
Yeah. Well, right now, I think from utilities, data seems to be, in the flexibility of the frequency. But I think our position is that voice will also be very important for
So
utility.
you have it set up for E911, setting up the PSAPs to set that whole process up?
No, we don't have that yet. No, thank you for that.
All by itself.
Yeah, that's a challenge in itself. But you see, Kev, it is your system, right? So you can integrate what you choose to put into your system. You don't have to ask the carrier, oh, that's another add-on and blah, blah, blah.
No, but if you're using it to process voice calls, aren't you required to be set up with 911 so that it can be used for that scenario?
Well, if it's part of a bigger network, yes. Yeah, these are standalone networks right now. Any other questions? Great. Well, anyway, thank you for attending the session and really appreciate your presence.